Before we actually start chapter 3, I want to go back and do some review on factoring quadratics because we're going to run into some factoring when we do these lessons, and so it's going to be important for us to make sure that we remember how to do the factoring. So the first thing we want to start with is to remind ourselves what factors are. Factors are quantities that are multiplied together to form a product. In other words, you're going to have one thing times another thing. Those are factors. The first thing we always want to look for when we're talking about factors is we want to look for a greatest common factor. So I'm not going to do this on every problem, but on this first one, I'm going to break it down completely using our prime factorization, and I want to show you exactly what's going on when we pull out a greatest common factor. So for this first term, we've got 3x squared. That means if we break it down into its parts, it's 3 times x times x. And each of those is a factor of the 3x squared. Minus, and then for the 6x, we would have, if you break down the 6, it's 2 times 3 times x. So the whole concept here, when we factor out a greatest common factor, is we want to find what these things have in common, these two terms. So notice they both have a 3 in them, and they both have at least one x in them, and so we are able to factor out a 3, and we're able to factor out an x from both of those terms. Then we write down our parentheses, and we want to think about, okay, what's left? Well, you can see that leaves us with an x right here, and it leaves us with a 2 right here. So what we have left is the x, and then the minus sign, and the 2. And so that is our method of factoring out a greatest common factor. Now, one thing that you want to understand here is when we factor this out, this is kind of the reverse of distribution. And remember, distribution, we multiply through the parentheses. In this case, we are actually dividing out a 3 and dividing out an x. And when we take that first term, 3x squared, and divide by 3x, so when we take this first term, 3x squared, and divide by this 3x, what we have left is x. When we take that second term, the negative 6x, and divide by the 3x over here, what we have left is 2. So if you ever wanted to check your factoring out a greatest common factor, you could just take your answer here and distribute back through and make sure that you get back to the exact same answer, which you should. So, like I said, I'm not going to write it out every time, but we're going to kind of think through the process. So if we think and we look at these, notice this time we have 3 terms. And we're going to start with the number part, and we want to think to ourselves, what number could we divide out of each of those numbers? So we've got an 8, we've got a 6, we've got a 2, and if you want to break them up, that's fine, but if you think about what could divide evenly into each of those, the biggest number that could divide evenly into all of those 3 is a 2. So we're going to factor out a 2. Then we're going to look at the x's. So notice here we have x to the 4th, and here we have x cubed, and here we just have 1x. So we want to factor out as much as possible, but we're limited here because notice the third term only has 1x in it. So the only thing we're able to factor out of all 3 of them is that 1x. Then we're going to look at the y's, and so here we have y squared, here we have y cubed, and here we have y to the 4th power. And again, we're limited by the smallest amount of them. So as far as what can we take out of all 3 of them, we can take out a y squared. And once we've figured out what we can factor out or divide out, then we're ready for our parentheses. So thinking about that division, if you take that 8 in the first term and divide by the 2 that we're factoring out, that's going to leave us with a 4. If you take the x to the 4th and divide out an x, and here you have to kind of think about what's going on. You've got 4 x's multiplied together, and you're dividing out one of them. Remember what happens is it's like they cancel, and there's going to be 3 left after you divide out that 1. And then when we take the y squared and divide by y squared, that's just completely gone. We don't have anything else there. So that's going to be the first term inside the parentheses is the 4x cubed. Then we go to the second term, the 6x cubed y cubed. So starting with the number, the 6 divided by the 2, that's going to leave us with a 3. The x cubed, dividing out an x, that's going to leave us with, same idea as earlier, is going to leave us with x squared. We'd have 2 x's left there multiplied together. Then we've got the y cubed, and we're dividing out a y squared. So that's going to leave us with 1y left over when we divide those out. Then we're going to put in our minus sign, and then 2 divided by 2 is just 1. I'm going to wait for a second because we don't have to put the 1 there unless that's all that's left. But 2 divided by 2 is 1, so that kind of cancels out. X divided by x is also 1, so that cancels out. Then y to the 4 divided by y squared is going to leave us with y squared. And then we know we have reached the end of our terms, and so that is our factoring out the greatest common factor for part B there. And really that's always the first thing you want to look for, because when we go on to more factoring, if there's a greatest common factor that you can factor out first, it's going to make the rest of your job easier as you work on factoring the rest of the stuff. So always look for that greatest common factor first. Now this one may not look like it, but for example 2 here, we're going to try to factor, and our factors, or I should say our terms, notice we actually only have 2 terms. They look a little bit funny, but we actually only have 2 terms, because the terms are those things that are multiplied together and then minus, and then the other term, whatever is multiplied together. So if you look at these 2 terms, hopefully you'll see that in each of these terms, whoops, I need to switch colors here. In each of these terms, you're going to see an x minus 3. And we are able to factor out that x minus 3. Now after we factor out the x minus 3, here's what we have left. In the first term, we still have this 2x plus 4. And then we have our minus sign. And then in the second term, let's see, I guess I'm going to use that. We're going to have the 5 left over. Okay? Now, here's what we want to understand. This x minus 3 is just going to stay out here. So we're really done with that part. But if there's any simplifying in here that we can do, we want to go ahead and simplify as much as possible. And at this point, these parentheses around the 2x plus 4 aren't really doing anything anymore. So really what this is we can forget about these parentheses, and this is just 2x plus 4 minus 5. So that will become 2x, and then when you have the 4 minus 5, it'll be minus 1. So that is, again, it's really the same thing. It's factoring out a greatest common factor. It's just that that greatest common factor looked a little bit different this time than it did in the previous examples. But it's the same process. The reason I gave us that last example is because we're going to learn a process right now called factoring by grouping. And you can use this process of factoring by grouping. It only works if there's an even number of terms. So if you look right here, we've got 1, 2, 3, 4 terms, and that means that at least we have a possibility of factoring by grouping. One thing I will remind us right now is it is not necessarily possible that everything factors. So we're not guaranteed that factoring by grouping works, but we're going to try it in these cases where sometimes we have an even number of terms. So I'm going to erase these lines here, but let me show you how factoring by grouping works. When we factor by grouping, we group our terms into halves. So we take the first 2 terms and we take the last 2 terms and we group them together. Then we look at each group individually and we take those 2 terms, in this case from the first group, and we factor them, factor out a greatest common factor if there is one. So we look at the numbers 12 and 4. And with the 12 and the 4, hopefully we can figure out that we can factor out a 4 from both of those. Then we look at the variables, the n cubed and the n squared. And again, hopefully, if you need to draw out a picture, that's fine, but hopefully you can figure out that you can factor out a 4n squared from both of those. Now we want to write down what's left. So again, we're dividing. 12 divided by 4 leaves us with a 3, and n cubed dividing out an n squared leaves us with 1n left over there. Oh, that's supposed to be an n. Let me fix that. There. Plus, and then we have the 4n squared. The 4 divided by 4 is a 1, and n squared divided by n squared is 1, so we are just going to put in a 1 there. So, and then we got a plus sign, but that part right there is the first half, and we factored out the common factor from that first half. Plus, and I'm actually going to switch this color here just so that we're going to do this a little bit differently. So when we look at the 3n and the 1, notice there's actually nothing we can factor out of this. So I'm just going to write down the parentheses, and since we can't factor anything out, we're just going to leave it as 3n plus 1. And that's the second part. Okay? But remember, what is always in front of a parentheses or in front of a variable or in front of any of those things anytime you write them? We don't write it down usually, but there's always actually a 1 in front of these things. So I'm actually going to put that 1 here in this case, and you'll see why in just a second. So now you'll notice I have these factored, and the first half is actually now just one big term, and the second half is now just one big term. And if you notice, in each of these terms, there is a 3n plus 1. So we are able to factor out the 3n plus 1 from both of those big terms. And once we factor out that 3n plus 1 in the first term, we still have the 4n squared, and then plus, and in the second term, we have just the 1 is left over. And in this case, there's no simplifying that we can do inside of either of these parentheses. So that is our factorization. So that original thing right up here with 4 terms was able to factor, and now it's factored into these 2 factors. And again, what that means is if you multiplied these out, the 3n plus 1 times the 4n squared plus 1, and you multiplied them out, it would be equal to this polynomial right here. So that's the process of factoring by grouping, and we're going to use that a lot throughout this lesson. So I want to make sure that you, if you've done it in the past, that you're reminded of it, and if you haven't done it in the past, that you get a chance to learn that. Here's another example of factoring by grouping. Again, 4 terms. So I'm going to group these first 2 together, and I'm going to group these second 2 together. And I did this on purpose, but you'll notice that this is not written in standard form. Notice the n term, the linear term, is before the n squared term, the quadratic term. And that's okay. The reason I did it is to show you what happens when there's a negative right here. Let's see. When there's a negative right here in front of that second part, the second half. So we look at the first half, 5n cubed plus 3n. And notice there's no numbers that we can factor out with the 5 and the 3, but we could factor out an n. So we're going to factor out an n, and that leaves us, when we divide out the n, with 5n squared plus 3. And that's now the first half, and now it's one big term. And then we have our minus sign. And when we have this minus sign here, that minus sign is part of what we're going to factor out. So we're going to factor out a negative, and then notice we can factor out a 2 from each of these numbers. And the first one has n squared, but the second one doesn't have any n's, so 2 is all that we can factor out of that second half. Or actually, I should say negative 2 is what we can factor out of the second half. So notice when we take, it's really a negative 10. Let me undo that. It's a negative 10n squared. So when we divide by the negative 2, it's going to make it into a positive 5n squared. And then when we take this negative 6 and divide by the negative 2, we're going to get a plus 3. And now that is the one big second term that we have for the second half of our 4 original terms. Once again, we can notice that, and I chose these so that they would work, but notice this second half is exactly the same inside those parentheses. So we are able to factor out a 5 n squared plus 3 from both of these. Then what's left in our parentheses in the first term is the n right here. And then we're going to have the minus sign. And then in the second term, notice we have still this 2 left over, so that's going to stay there. And that is going to be our factorization of that original 4-termed polynomial. So again, what that means is if you multiplied this back out, you would get to this. But our goal is to factor it, because when we have things broken into factors, it's going to make the rest of our life a lot easier. Now we're going to get to the quadratics. So remember, a quadratic has the form of a number, a in this case it's listed, times x squared, plus a number times x plus another number. So the way we write that is a times x squared plus b times x plus c. So that's just our example of a quadratic. And we're going to go through, and you don't have to worry about if a is not equal to 1. We're just going to use this 4-step method all the time so that we don't have to be mixing and matching. But here's the process we're going to use. We're going to multiply the a value times the c value. So notice that's the first coefficient times the last coefficient. Then we're going to, and I'm going to go through all these steps in our examples, but then we're going to find the factors of a times c, and we're going to find the factors of a times c that add up to be the b value. Then we're going to rewrite our expression, and we're going to replace the b in our original expression with these two factors that we come up with. And notice when we do that, and you'll see this in the examples, but now we're going to have 4 terms, and so then we're going to be able to factor by grouping. And so that's the process we're going to use as we go through these, and we're going to do this a lot of times, so you're going to get, hopefully, really familiar with and really good at doing this process. But we do want to, again, stress that we always want to look for our greatest common factor first if we're going to try and factor something, because then that's going to make all the numbers and variables and stuff, exponents, smaller than they would have been if we had not taken out that greatest common factor. So let's start with this first one. We're starting out kind of with a basic one. Now, automatically, what number is in front of the x squared? And hopefully all of you are thinking there's a 1 automatically in front of the x squared. So what we do is we take this 1. Step 1 is take a times c. So we're going to take 1 times 12. And that equals 12. Okay? So that's the first step. Then our next step says we're going to find factors of a times c. In this case, that's 12. That will add up to be b. So in this case, that's a 7. Now, I want us to kind of think about this, because I could start listing a whole bunch of different factors, and as you do this, you're going to get better and better at it. But I want us to think through this first of all. So the first thing I want us to think about is, since this is a positive 12, that's supposed to be a plus sign. It's a positive 12. And since it's a positive, if you're multiplying two numbers together and getting a positive answer, what that tells you is those numbers that you're multiplying together are either both positive numbers or they're both negative numbers. And that's going back to our rules for multiplication. If you multiply two positive numbers together, the answer is positive. If you multiply two negative numbers together, the answer is positive. And that's the information that we're using right here. So when we start looking for these two factors of 12, two numbers that multiply together to equal positive 12, we know they're both positive or they're both negative. So that's the first thing we know from the fact that that is a positive 12. The second thing we know is, since this is a positive, these two numbers that we're looking for in part 2, step 2, have to add up to be 7. If we look at our options, remember they're both positive or they're both negative? This tells us they both have to be positive, because if you add two negative numbers together, you get a negative. They multiply to be a positive, but they add up to be a negative. So we are going to be looking for two positive numbers. And that helps us as we go to start listing our factors of 12, because we know we're only going to look at positives. So our first option is 1 times 12 equals 12, but 1 plus 12 does not equal 7. So I'm going to put a little plus sign in here just to kind of illustrate this. This is 13, it's not 7. The next option, and I usually start with 1 and I just go up. So 2, and 2 times 6 equals 12, but 2 plus 6 equals 8. So that's not going to work out for us. Then I go up, 1, 2, okay, we go to a 3. 3 times 4 equals 12, okay, so it's another set of factors. And in this case, 3 plus 4 equals 7. Hey, we have a winner. That's the two numbers we're going to use, the 3 and the 4. So here's what we do at this point. We're going to take this expression and we're going to rewrite it. X squared. But instead of the 7x, we're going to put in these two numbers right here. So we're going to put in a plus 3x and a plus 4x. And then we write down the plus 12 at the end. And the reason that we are allowed to do this is because 3x plus 4x is equal to 7x. So we are substituting in the 3x and the 4x in place of the 7x, and we can do that because they're equal. Hopefully you notice now it kind of looks like the ones we've been doing. Notice we have 4 terms, and we're going to factor. So in our first term, notice we have a common factor of an x, and what's going to be left over is, I guess I'm using red here, x plus 3. Oh wait, no, let me undo that. Hang on, sorry. Not that it matters, but I don't want to switch colors yet. Plus, and that's the first part, plus, and then in the second part, we can factor out a 4 from both of these, 4 and 12. And when we divide out the 4, we're going to have the x, and then we're going to have plus 3. Now, in these problems, so here's our second half, but in these problems, if we did our job right over here, these two factors should always match up. If we did our job right over on the right-hand side, finding those factors, these factors over here on the left should always match up. So we're going to be able to factor out the x plus 3 from both of these big terms now. And then what we have left from the first term is the x, and what we have left from the second term is the plus 4. And that is our factorization of the x squared plus 7x plus 12. Okay, so x plus 3 and x plus 4. And you may note, and I'm going to come back to this in a minute, but you may note that the plus 3 and the plus 4 are the same as the 3 and the 4 that were over here. Sometimes that is true, sometimes it is not. I'm going to do our next example, and then I'm going to talk about when that's true and when it's not necessarily true. Example 4, again, very similar. We can think of this as a 1x squared, and we're going to take the 1 and multiply by the negative 3. So 1 times negative 3 is negative 3. And then we're going to look for the factors of negative 3, but before we do again, I want to look at these signs. Notice this time it's a negative 3. When you multiply two numbers together and you get a negative answer, the only way that happens is if one of the numbers is positive and one of the numbers is negative. So if you multiply numbers together and they have different signs, that's how you get a negative answer. But then we also want to go back over here and we want to look at this sign. Because we know these factors that we're looking for have to add up to be a negative answer. So if you are adding a positive number and a negative number together and you're getting a negative answer, what that tells us is the bigger one here is going to be the negative, because the negative one is outweighing the positive, because when you add numbers together that have signs, whichever one is bigger outweighs the one that's smaller. So when we write our factors down, we're going to write down a positive one that's small and a negative one that's big. So when we start listing these and I've got 1 and 3, I'm going to make sure I put the negative with the 3 because that's the bigger number of those two. And notice what happens there when we take 1 and add it to a negative 3, we get the negative 2 that we need. I didn't give myself enough space to write it there, but this is the one, these are the two numbers we're going to use. So we're going to rewrite this now once we find those two numbers, x squared, and remember we're going to replace the negative 2x with a plus 1x and a minus 2x, sorry, that's not true, minus 3x, and then minus 3. Then we're going to group them in halves again, in groups. And notice in the first group, again, what we're going to be able to take out is an x. And that will leave us with an x for the first part and a 1 in the second part. Minus, and in this one we can take out, remember we have to take out this minus sign, so that's automatic. We're going to take out a minus. And then we've got a 3. And when we divide out the 3, notice negative 3x divided by 3 is x. Negative 3 divided by negative 3, these two, is going to be a 1. So again, here's our first big term and our second big term. And you will notice that the factors inside of each of those are the same. And again, that's guaranteed as long as we did our job correctly over here. But we're going to be able to factor out the x plus 1 now from both of those. And once we've factored out that x plus 1, what's left in the first term right here is the x. And then what's left in the second term right here is the minus 3. And so that is going to be our factorization for that one. Now, again, I want us to realize that the 1 and the negative 3 are the same 1 and negative 3 that we had over there on the right. That will actually happen every time that the x squared only has a 1 in front of it. So it's kind of a special case. So if we see that the x squared has a 1 in front of it, and we get these two numbers right here, we can actually go straight to x plus 1 and x minus 3 without doing the factoring by grouping. That's the only time that we can do that, is if this x squared up here only has a 1 in front of it. Anytime there's any other number, then we're going to have to go through this process. Okay? But even if it doesn't have another number in front of it, you can still use this factoring by grouping and it will always work. So that's why I showed you the factoring by grouping. It will always work if your quadratic is factorable. Now, let's move on to some that look a little bit different. Notice there's a 7 in front of the x squared. But before you jump to multiplying the 7 times the 28, the first thing we should look for is, can I factor anything out of all three of these terms? Because if I can factor the 7 out, then I don't have a 7 in front of the x squared, and that's going to make our jobs easier. Unfortunately, in this case, even though the 7 factors out of here and the 7 factors out of here, the 7 will not factor out of a negative 45. 7 does not divide into negative 45 evenly. So we can't do that. So then we will go ahead and multiply 7 times 28. I should have grabbed my calculator. Hang on, I do have a calculator here. So with your calculator, there's no reason to, I mean, if you can do it in your head, go ahead. But if you've got your calculator, just grab that, and you're going to take 7 times 28. And when we multiply 7 times 28, we are going to get, my battery's almost dead, 7 times 28, and we are going to get 196. So 7 times 28, negative 28 is negative 196. So looking at that and remembering what we did before, we want to think about this, the fact that this is a negative. And if that's a negative, and you can see it right here, that means the two numbers that we multiply together are going to have different signs. One is positive, one is negative. Then we go back over here, and we know that when we add them together, we need to get a negative answer. So that means the bigger one in this case, again, just like the last one, is going to be negative. So now as we start listing these, we know the negative is going to go with the bigger answer. So I usually, again, start with 1 and negative 196. That obviously does not add up to be negative 45. 2 and negative 98. And what I'm doing here is I would just take my calculator and take 196 divided by 2, and that'll give us the negative 98. 3 will not divide into 196. You can check that with a calculator, but it doesn't work. 4 times negative 49. And again, just 196 divided by 4 equals negative 49. And notice that's going to work. 4 plus negative 49 is negative 145, or sorry, negative 45. So we are going to rewrite this. 7x squared plus 4x minus 49x minus 28. And again, remember the reason we can do this is because this 4x and the negative 49x together equal the negative 45x. Now we're going to group them. And in the first group, notice we can take out, looks like just an x. And we will have 7x plus 4 left over. In the second group, remember whatever this sign is, we have to take it out. So in this case, it's a minus sign. So we're going to factor out a negative. And 49 and 28, you might have to do a little bit of work there, but 7 will divide evenly into both of those. So when we divide out a negative 7, it's going to leave us with 7x, and divide the negative 28 by a negative 7, and that's going to be plus 4. So again, just a reminder, if we did our work correctly over on the right, these two factors should match up. And so now we've got the big first half here, and the big second group also. So we are going to be able to factor out this 7x plus 4. And when we write down what's left, after we factor out the 7x plus 4, we've got an x right there in the first term, and we've got a minus 7 right there in the second term, and that is going to be our factorization. And again, I keep repeating this, but I don't want us to lose track of the fact that what this means is if we multiply these together and distribute them and multiply them out correctly, they would equal the first thing. So that's what we're doing, is we're taking that first polynomial that has 3 terms in it, and we're breaking it down, because when we get to solving equations, it's going to be easier for us to do that if we can factor them first, and we're going to see that at the end of this lesson. Next one here, we've got a 2, and you just want to look, can you factor anything out of all of these? And the answer is no, because the middle one's a 1. So we're going to take the 2 times the negative 6, and we can see that that's negative 12. Once again, we want to look at the fact that this is negative, and when you multiply two numbers together and you get a negative answer, one of them had to have been positive and one had to be negative. This time, when we add them together, though, we need to get a positive 1. So that means when they have different signs and the answer has to be positive when we add them together, the bigger one this time is going to be positive. So let's start listing these out. So the bigger one's positive. So a 1 and a 12, but we need the bigger one to be positive and the smaller one negative. So that means negative 1 and positive 12. That doesn't add up to be 1. Then we could have a negative 2, and we divide that into negative 12, and we would get a 6. Wow, that's a bad 6, but that's a 6, and that doesn't add up to be positive 1. 3, a negative 3 dividing into 12 would give us a positive 4. And that's the one that's going to work. So we're going to use the negative 3 and the positive 4. So again, we rewrite this. And this is very repetitive. Once you learn the process, it's easy to do. You always do the same things. So 2x squared. We will write down the minus 3x and the plus 4x and the minus 6. And once again, notice the reason that this is okay to replace these is because these two together equal that 1x. We are going to group the first half and group the second half. And when we factor this, notice in the first one, again, this time we just have an x that we can factor out, and that will leave us with 2x minus 3. Then on the second group, we have to take out this plus sign, so it's going to be plus. And then when we look at these numbers, we can factor out a 2 from both of them. And that will leave us with 4 divided by 2 is 2x, and negative 6 divided by 2 is minus 3. And notice once again, these are the same, and they will be as long as you did your job right over here. So first half, second big term, you'll notice that we can factor out the 2x minus 3 from both of them. And what we have left then in the first term is going to be the x. And what we have left in the second term is that plus 2. And again, once we get to that point, we are done. I guess I haven't mentioned it, but one thing that some people sometimes get worried about is, well, what if my numbers over here are in the reverse order? What if I have the 4 on the left and the negative 3 on the right? And so when I put them in right here, I have the 4 on the left and the negative 3 on the right. And the answer is, it won't make any difference. All that will happen is, when you get done, your terms down here will be reversed. It will say x plus 2, and that'll be on the left, and it'll say 2x minus 3 on the right. And that's exactly the same thing, because when you multiply, the order that you multiply in doesn't make any difference. So it doesn't make any difference if our answer looks like this, or if our answer looks like this. Those are the same. So don't be worried about if your order is different than mine when you plug them in up here. That's not going to make any difference in the final answer. The work will look just a little bit different, but the final answer will be the same. Next, again, we've got a 2 in the front. So we look, can we factor out anything from all three of these? And unfortunately, no, the 13 messes us up, and we can't factor anything out of all three of these. So we are going to go back to a times c. This will be 2 times 20, and we can see that that is 40. Not only is it a 40, but we want to recognize that it's a positive 40, because when it's a positive number like this, and you multiply these two together, one option is like what you've got right there. It could be a positive times a positive, or the other option is it could be a negative times a negative to give us the positive 40. Once we know that, we go back over here and we say, okay, these have to add up to be a negative. The only way to get that is if they're both negative when we add them together. Okay, because if we add two positives, you'll get a positive. So let's start writing these down, and we know they're both negative. So negative 1 divided into 40 gives us negative 40. That doesn't add up to be negative 13. Negative 2 divided into 40 gives us negative 20. That also does not add up to be negative 13. 3, you could check it, but that doesn't divide into 40, so negative 4 is the next one, and that would give us negative 10. And that does not equal negative 13, but it's pretty close. Negative 5 divides into negative 40, and you get negative 8, and there's the one that will work for us, because negative 5 plus negative 8 equals negative 13. Once again, repetitive, it's going to be rewritten 2x squared minus 5x minus 8x and plus 20. We've got our first half, we've got our second half. The whole goal there is we're breaking that middle term into two terms so that we can use the factoring by grouping. So, looking at the first group, we've got a 2 and a 5. Nothing happens there, so we can just factor out an x, and we will have 2x minus 5 left over. Then in the second one, remember we have to factor out the negative. So we're going to put down our negative sign, and in this case we can also factor out a 4. So we're going to divide out a negative 4, and negative 8x divided by negative 4 will leave us with 2x. 20 divided by negative 4 is going to leave us with a minus 5. That shouldn't be any surprise to us because they should come out to be equal when we look at those two factors. So, what can we factor out of both of them? We can factor out the 2x minus 5. Then what we have left is, in the first half we have the x, in the second half we have the minus 4, and that is our set of factors. So again, it gets very repetitive, but it's really important that you understand the process. So I know we've done a lot of these, but that process is very important, and it's something that people struggle with. But if you learn this process, you just list the numbers, and if you can find two that work, the negative 5 and the negative 8 in this case, to add up to be negative 13, The rest is just very repetitive, and you kind of always do the same thing. So factoring is not hopefully something that you're going to have to struggle with, but hopefully you just kind of keep practicing and get better and better at it. We have one more of these that we're going to look at, factoring, just factoring. And again, we want to look at, we've got a 5 in the front, in front of the x squared. Can we factor anything out of all three of these? And no, because 5 doesn't factor into 24. So we will take a times c. That is 5 times negative 5. And that equals negative 25. So examining our signs, we know this is a negative. The only way to get a negative is a positive times a negative. Then we look back over here and they add up to be a positive, so that means the bigger one has to be positive. So when we write down our first pair, we're going to have a 1 and a 25. The big one's positive, that means the little one has to be negative. And actually, that one works right away. So we don't have to write down any more options. The first one works. We can stop when we find one that works. So we want to rewrite this 5x squared minus 1x plus 25x minus 5. And again, the reason this is okay is because those two middle terms are equal to the middle term in the original. So let's group these. Notice in the first group, all we can take out again is the x, and that leaves us with a 5x minus 1. And then again, we have to take out that sign, whatever it is. In this case, it's a plus sign, so that's pretty easy. But we can also take out a 5 from both of those. So we're going to factor out a 5, and 25 divided by 5 gives us 5x, and then negative 5 divided by 5 is negative 1. Once again, those terms are the same. We're going to be able to factor out a 5x minus 1 from both of these. From our first group, we're going to be able to factor out, or what's left is going to be the x. And then from the second group, what's left is going to be the plus 5. And we get our factors. So again, I know repetitive, but the process, once you learn it, it will work for you on any one of these quadratics that is able to be factored. I will mention now, since I'm talking about is able to be factored, if you go through and you list all the different possibilities and none of them add up to be your b value, double check to make sure you did it right. But if that happens, it just means that the quadratic you're dealing with is not factorable. So you would just write not factorable or whatever. On the computer, they may ask you to write some other, like not possible or something, but it'll usually say in the directions. Now we have a few special forms that pop up once in a while when we are doing this factoring. One of them is the difference of squares, and this is probably the only one of these that I would suggest that you that you memorize, because it's going to make your life a lot easier. We can use the method we've been using, and I will show you that, but it's going to be much easier if you can remember this method of factoring, this pattern. So the difference of squares, you'll notice it's a difference, it's subtraction, and then the first number, the first term, and the last term both have to be perfect squares. And if that's the case, then it will factor to be this first part plus the second part, a plus b, and then the first part minus the second part. And again, I'm going to show you that pattern, and then we will, then I'll show you how to do it using the other method that we have been using already. The other two methods, I wouldn't bother trying to memorize these. It does always work if you recognize this pattern, but these patterns are a lot more complex. But just understand that sometimes you'll end up with two factors that are actually exactly the same, and that just means that it was one of those special patterns, even if we didn't use those factoring methods or those patterns to actually do the factoring. But that's not an issue for us. So this example, and notice I've labeled it as the difference of squares, and we can tell that it's the difference of squares for this reason. First of all, we have to have a difference, so it's minus. And then the second thing that has to be able to be done is you have to be able to write it as a perfect square minus another perfect square. Okay, so if we think about this, what times itself will equal, and I'm going to use a different color here, I'm going to use blue. What times itself will equal 9x squared? And the 9 part's pretty easy. We know 3 times 3 equals 9. And then hopefully it makes sense that x times x equals x squared. So 3x in that parentheses gets squared, and that equals the 9x squared. Then we have the 16, and hopefully again that one is fairly easy. 4 times 4 equals 16. So that's what we're doing. We're replacing those two terms with the perfect squares. Once we have done this, we just follow the pattern. And here's what the pattern says. We're going to have a parentheses with a plus in it and a parentheses with a minus in it. And once we have that, we just fill in the blanks. So it's going to be the first part, the 3x, plus the second part, 4, and then the first part, the 3x, minus the second part, 4. And so without doing any of the work that we had been doing before, we can factor this, and it works out to be 3x plus 4 times 3x minus 4. And so that's the benefit of difference of squares, is it works out really quickly and really pretty easily if you can recognize that pattern. Now let's say that you didn't recognize the pattern. This is going to look a little bit different because you've got, so this is just doing it the old way that we have been doing previously. If we had 9x squared minus 16, notice that's the a term and the c term, but our b term, since there's nothing there, would be 0x. So if we want all three pieces, that's what goes in the middle, is the 0x. And we can't factor anything out of both of these, so we would have to take 9 times 16, negative 16. So if we do that, I'm going to grab my calculator just to double check. I think it's negative 144, but just to double check. Oops. I need to hit the right buttons. And it is 144, or negative 144. So once again, if we go through our process of taking a look at these signs, this one means that one of them is positive and one is negative. And then here's the weird thing. Right here, since they have to add up to be 0, what that means is they're the same number, but one is positive and one is negative. Neither of them are bigger. So you can go through your numbers, 1 and 144 and 2 and what would that be? 72, and 3 goes in there 36 times. No, that's not 36. Hang on. What is it? 48 times. And 4 goes in there 36 times. And 6 goes in there 24 times. 8 goes in there. Come on. 8 goes in there 18 times. 9 goes in there a whole bunch of times. But really the key is this. What times itself equals 144? And the answer is 12. So that means one of our 12s is positive and one is negative. So we would write this out as 9x squared plus 12x minus 12x minus 16. And we could do this exactly the same way as we did it before. So looking at our first group, we can factor out a 3 and an x from both of these terms. And that will leave us with 3x. And dividing 12 by 3 is a 4. Then remember we have to take out that negative sign. So we're going to put a minus in here. And in these we can factor out a 4. And that will divide out a negative 4. We're going to get positive 3x. And negative 16 divided by negative 4 is positive 4. Notice once again how these are the same. So from our first group, we're going to factor out that 3x plus 4. And what we're going to have left is the 3x that you still see underlined there. And then from the second group, we've still got that minus 4. And notice, it's the exact same answer. So we can do it either way, but the first way, if we can recognize it, is going to save us a lot of time. So I would suggest, if you see just two terms like that, see if you can do this pattern of the difference of squares. So this one, we can see there's only two terms, so we should look. Oh, perfect squares. Unfortunately, 12 and 75 are not perfect squares. However, look for your greatest common factor. What can we factor out of both of these? And it might take a little bit of work, but actually, we can factor out a 3 from both of them, and that will leave us with 4m squared minus 25. Now we can see, hopefully, now we can see that these are perfect squares. So I'm going to put brackets here because the 3 has to stay there. How could I rewrite the 4m squared as a perfect square? Well, 2 times 2 is 4, and m times m is m squared. Then we've got the minus sign, and we should have another perfect square over here. And hopefully we're pretty quick to find out that that's 5 times 5. And once we have that, we've got the 3 in the front, but here's the pattern. We're going to have 2m plus the 5, and then we're going to have the 2m minus the 5. And you include that 3, that common factor, that stays out in the front. You don't have to deal with it anymore after you factor it out, but it does stay out in the front of all your other factors. So that would be our answer for that one, using our pattern for the difference of squares. Now, I'm not going to specifically do any of those examples like the last one, the last two, I should say, where we've got patterns where they come out to be the same factor. But the one other topic we do want to talk about and review from our previous math lives is where we solve things by factoring. So the first thing we're going to do is factor, and then I'm going to show you, once you factor them, how do we solve them. So let's start out with the factoring. Notice there's no common factor here because there's nothing we can factor out of each term. So then we're going to take the 4 times the negative 15. So 4 times negative 15 gives us negative 60. And again, you can do that on a calculator. Then we want to look at the fact that this is negative, and remember that means one is positive, one's negative. Then we look back over here at the b term, and since that's a positive, that means the bigger one of these two is going to be positive. So now we just start listing them. 60 has a lot of factors, unfortunately. So bigger one's positive, that means the negative 1, and then that goes in there 60 times, so that doesn't add up to be 4. Negative 2 would divide in there 30 times. That doesn't equal positive 4. Negative 3 will divide in there 20 times. That doesn't equal 4. Negative 4, we already know that would be 15 times. That doesn't equal positive 4. Oh, 5 goes in there 12 times. We're getting closer, but that doesn't equal negative or positive 4. 6 divides into negative 60 10 times, and that's the one that works. So let's go ahead and write this down. 4x squared minus 6x plus 10x minus 15. And this time we have that extra piece equals 0 because eventually we're going to have to solve this. So let's do our factoring. First group, second group. Notice we can take out a 2x from both of these this time, and that will leave us with 2x, and then 6 divided by the 2 is going to be a negative 3. And then we have our plus sign that we would take out. And let's see, what can we take out of here? A 5. So divide out a 5, and we would have 2x minus 3, and then equals 0. So again, no surprise, we were able to factor it. They're the same. We're going to be able to factor out 2x minus 3. What we have left from our first group is a 2x, and from our second group, a plus 5. Okay, now in all the other problems, we were done at this point because none of the other problems had this equals 0 at the end of it. This one is different. We have to solve. We're going to figure out x equals what? So what we do at this point is we're going to take each of these factors and set them equal to 0. Now here's why we do that. This is going back to something you learned way back when. Anytime you multiply by 0, the answer is 0. So the idea is if 2x minus 3 equals 0, that 0 times 2x plus 5 will equal 0. Or if 2x plus 5 equals 0, when you multiply that times 2x minus 3, the answer will be 0. So these are the two ways that we're going to be able to make this equation true. So once we've got this written down, we just do our little algebra here, add 3. And we would have 2x equals 3. And then to cancel out the 2, we're going to divide by 2. And we're going to get x equals 3/2. And that's one of our answers. The other one, we'll do similar steps. We're going to have to subtract 5 to cancel that. And then we have 2x equals -5. And then we divide by 2 to cancel out that 2. And that's going to give us x equals -5/2. And again, I believe that on the computer, they usually want those in fractions. So if you want to get used to just leaving it as -5/2, if you want to use your calculator to reduce, that's fine. But I think, if I remember correctly, most of the time they want this in fractions. So those would be your two answers. And I think you just put in like a 3/2, comma, and then -5/2. Okay, we've reached our last example here, and again, it's factor the following expression and solve, so the main point here is factoring, but we want to remember how to solve as well. There's nothing we can factor out of all the terms. There's no greatest common factor, so we're going to take 5 times 20, and we actually get 100. And again, we know that's a positive 100, so when it's a positive, you could have this, two positive numbers multiplied together, or you could also have two negative numbers multiplied together. And then when we go over here to the b term, since they are both positive, since the b value is positive, that means the numbers we're adding together have to both be positive. So 1 and 100 does not add up to be 29. 2, and that goes in there 50 times. That does not add up to be 29. 3 does not divide into 100. 4 divides into 125 times, and that is the answer we're going to be able to use, or the two factors, so 4 and 25. So let's write this down again. We've got 5x squared. Then we're replacing the 29 with the 4x and the 29x. And then we have plus 20. And don't forget the equal 0 on the end of this one, because this one is an equation. We've got our two groups here. From the first group, we can factor out just an x. And that leaves us with 5x plus 4. Then in the second group, we have to take out this plus sign. So it'll be a plus, and then... Oh, wait, I wrote that wrong. Hang on. We replaced the 29 with the 4 and the 25. I'm sorry about that. Hopefully that doesn't mess anybody up. Right here, that should be a 25, not a 29, because the 4 and the 25 equal the 29. So I knew that I had messed up something, because 29 and 20, there was nothing in common. But with 25 and 20, we can factor out a 5. And that leaves us with 5x, because 25 divided by 5 is 5, and 20 divided by 5 is 4. So once again, these are the same, so that's good. We can factor out 5x plus 4. Then what we have left in our first half, the first group, is the x. What we have left in the second group is the plus 5. Close our parentheses, and those are the factors. Now remember, with this one, this is an equation. This is equal 0. We're not done yet. But what we're going to do then is we take each factor, 5x plus 4, set it equal to 0, and also the x plus 5, set it equal to 0. So for the first one, we're going to have to subtract 4 from both sides to cancel out that plus 4. And we have 5x equals -4. And then we're going to divide by 5. And we find out that for this part, x equals -4/5. So that will be one of our answers. For the second one, it's actually much easier. There's just one step, subtract 5. So that cancels, and we get x equals -5. So again, when you put those in the computer, I think they just have you put them in with a comma in between, and those would be your answers for that one. So again, the process of factoring, it can be very repetitive, but because it's repetitive, it means that if you learn the pattern, you will be able to factor these. So that's going to be the key thing for this review section, because we're going to be using this throughout the rest of the semester. You have, whoops, it hasn't updated yet. There we go. You have 10 problems on your supplemental section there. I can't remember exactly. I think it's just labeled like supplemental section or review section or review of factoring or something like that, but it's going to be before section 3.1, and you can go ahead and work on those. And again, please, if you have questions, don't hesitate to email me and ask me if I could help you with explaining those.